Alright, let's see what's got here. Previously solved easy. Find x sum of all k long subarrays. Part 1. You're given an array nums of n integers and 2 integers k and x. This x sum of an array is calculated by the following procedure. Count the occurrence of all elements in the array. Keep only the occurrences of the top x most frequent elements. If two elements have the same number of occurrences, the element with the bigger value is considered more frequent. Okay. Calculate the sum of the resulting array. Keep the top x most frequent. Okay. So what? Count the occurrences of all elements. Keep only the occurrences of the top x most frequent elements. Oh, they give you x. 2 integers k and x. Top x most frequent elements. What is k? Return array answer of length n minus 1, n minus k plus 1, where answer phi is the x sum of subarrays. Oh my god, what the hell is this? Nums of I to I plus k minus 1. Okay, so the top two occurring top x most frequent elements. So I guess that'd be 2 occurs 3 times, and both 1 and 3 occurs 2 times, so therefore it's going to be 3. The subarray 1, 1, 2, 2, 3, 4. Return an integer array answer. For the subarray 1, 1, 2, 3, 4, that subarray only elements 1 and 2 will be kept. Oh, I see. K is, so you're making a subarray. K is the length of every subarray that you're looking at. So you're looking at all 6 length subarrays. And then for each of those, you're trying to find the top 2 most frequent elements. So what's going on here? So only elements 1 and 2 will be kept because they're the most frequent. So the sum of 1 and 2 is 6. Okay, and the second subarray, 2 and 4 would be it. So 2 plus 2 plus 2 plus 4 is 10. And then the last 6, most frequent would be 2. Second most frequent is 3. So 2 plus 2 plus 2 plus 3 plus 3. So that's 12. How is this supposed to be an easy? How is this supposed to be easy? Seems more like a medium to me. Alright, just going through one more example to make sure I'm doing it correctly. So 3, 8. Okay, it's kind of a trivial one. Wish they sometimes give you one more kind of non-trivial one before they give you like the stupid stuff. So it's just the sum of the 2 elements, because yeah, it's pointless. 3 plus 8, 8 plus 7, 7 plus 8, 8 plus 7, and 7 plus 5. Okay, so you want to keep a window, and you want to know what the most frequent stuff is within the window. Seems like it might be a heap. Alright, how big is this? Oh, it's pretty short. 50. Okay. So you could do something pretty slow in terms of like creating each array and then creating each subarray of length k and then actually doing the actual count for that. Question is if it'd probably be something like n times k, where n is the length of the array and k is the subarray length. There's probably a O of n solution here. You keep track of, what do you need to keep track of? Okay, so the initial array is 1 through 4. You'd use a heap. Generally, frequency stuff is maybe kept with a heap. What would you put in your heap? Would have like the frequency and the value as a tuple. So it's like 2, 2, 2, 1, 1, 3, 1, 4. And then pull out the biggest two tuples from your heap, so it would be the 2, 2 and the 1, 1. And then what? And then you obviously take the sum of those, that'd be 6. And then you and then you would remove, see how you remove the 1 and remove 4 and add in another 2 somehow. What is k? K can be the length of it. K is the length of it. It's not actually pretty simple. Then it'd just be, there'd be only one subarray. Guess you could use a heap, and then when you pull stuff off the heap, you cross verify. So you have another data structure to track the frequency of items inside the current window, current subarray. Update the window, add another element, update with the window, add onto the heap the tuple. Guess the heap is going to be at most n size, really. It's not going to be very fast, though. Okay, let's try it. So it's going to be frequencies is going to be a default dictionary, maybe. The values are 1 through 50. Okay, guess I can just use an array. A hard array for that. index in the array is the actual value. So I need a first. Ugh. When use the top x, technically you normally use two heaps for that, or the top x and the bottom non-x values. Then you're dealing with stuff that's outdated. Oh god, I hate those. I hate them so much. The problems where I have to use two heaps. One for like the top three and the other for the bottom non-top three. Generally just make so many mistakes when I try to do those type of problems with heaps. One, two, three. Top x. Top x. So let's put a heap of size 2. Say x is 3. Kept a heap of size 3. So I'd be adding like 1, 1. And then tuple that is 2, 1. And then a tuple that is 1, 2. Fortunately, the issue is when you update the heap to update the heap for values that are already in the heap. Some of the heap becomes outdated. I wonder, what if I top 2? Yeah. So if you Man, this really... I wonder if there's a part 2 to this. 3318. I wonder if there's a 3319. No. X-ray of all long subarrays part 2. It doesn't seem like there's... Well, it doesn't immediately follow. Count all occurrences of all elements in the array. The occurrences of the top X. The X sum of an array. What we're doing for the subarray. So, okay. Let's be okay, so let's say the heap is for the first 6, 2, 1, 2, 2, 1, 3, and 1, 4. 2 1s, 2 2s, 1 3, 1 4. The heap has to order it such that, probably in reverse order, really, so that they, rather than ascending, it would be descending, so that the 2 2 is the first thing in the heap. And then, so you take the first 2. Guess there should be like heap X and heap Y, where X is the top X things and heap Y is the rest of it. So the heap X is the top X2 frequency. Technically, maybe heap Y has something there that is like maybe 1 1 and 1 2. For the first time it comes across the 1 and the 2, the frequency of those values is 1. And then what happens? So then the index becomes, the end of the subarray becomes 2. So then you would have like a 3 2 here. 3 2 added to this heap. And then you would need to somehow remove the 2 2 as being outdated. And you'd have a 2 1 3 2. No, the 2 1 is also outdated because there should only be 1 1 left. So then the 3 2 is the only not outdated, and you need another one pulled from the other one, so it'd be like a 1 4 pulled. Three, 4, 5, 6, 7. One of these is outdated still. Yeah, this is outdated. top. Keep only the currents of the top X most frequent elements. Top X most frequent elements. Two elements have the same occurrences. The element with the bigger value is considered more frequent. Man. Can't modify. Can't really modify stuff in a heap. So if there's like two twos on the heap, or a tuple that is two frequency two value, you can't just change it to be two, like three frequency two value. Top X most frequent elements. I wonder if we could sort each time. That is nasty. Sorting. So what would that mean for each? Yeah, we could sort it, I guess. That's just ridiculous. Okay, let's try something. Say values is a set of stuff that is in the current window. For the first, let's say n is the length of it. For the first k in range of n minus k, no, k is used. For index in range of k minus 1, I want to say. I think k minus 1. Values, add the value at the index. Frequencies of, okay. Value is nums at this index. Values added to the set. Frequencies of this value, increments. So this is everything besides the last element in the subarray. Just the initial thing, so that this is the setup for first kind of k minus 1 values. Then this is this kind of sliding window for last value in subarray. So for every index in range k to n, might be k minus 1 to n. So the value is nums at this index. So I want to add the value, remove the last value. Remove value is going to be nums at index minus k. K is 1. K minus 1. K minus 1 minus k is going to be negative 1. Miss something here. 0 to k minus 1, k minus 1. Index minus k plus 1. Doesn't seem right. If k is 3, then the first loop goes to 0 to k minus 1 be 2. First loop does 0, 1. And then the second loop starts when index is 2. Okay, so yeah, okay. Remove values done afterwards. Okay, so I have the value, which is the last value of the subarray. I should add the values, add this value, frequency update, and then find top X frequency. So I think I do want a heap here. For every value, for every, let's say, v in values, I'm going to say heap dot append I want a heap here. I just want to sort. Yeah, I guess I do want to. Guess I can keep a heap. Think. Yeah, heap dot append tuple, that is the frequency of the values, so values or frequency of this value. Frequencies, it should be plural. Frequencies of this value, comma, the value itself. I guess in this case it was v. And if this needs to be backward sorted. Same thing, it should be negative, negative. And if heap size is more than x, then I need to pop the heap. Pop the smallest. Actually, I guess I do want it to be increasingly sorted. So the smallest is the value that has the least frequency. Okay, and then afterwards I'm going to calculate what the top whatever is from the heap. So for every frequency value in the heap answer, total is going to be 0, total plus equals frequency times value, and then answer append the total. And then I need to slide the window. So index, if k is 3, k minus 1 is 2, so it should be index minus k plus 1. index. Yeah, this one. And then frequencies of the remove value increments. If that frequency is now 0, then move that from the value set. Okay. Let's see what errors I have. Remove value. Misspelling. Remove val. 8, 10, 10. Okay, let's go ahead and see what's inside the heap at each. So there should be 3 printouts here. 1, 4, 2, 2. Eeks! Eeks, indeed. It should be 2, 2, 2, and 2, 1. 2, 2, and 2, 1. If length of heap is greater than x, or x is 2. Really? Okay. Okay, what's the values that it sees here? So it sees 1, 2, 3, 4. Sees 1, 2, 3, 4. The frequency, it should be 2, 1. It should be 2, 1. Oh, I see. I call this a heap, but I just use it as a freaking list. Okay, this would be heap push, heap, and then dot tuple. Okay. Wow, that was really unsatisfying. Well, I mean, okay. Guess this was a lot easier than using 2 heaps. Guess the other solutions probably didn't use a heap, to be honest. They might have used some sort of sorting, which would have been slightly slower. Okay, so this is kind of like a sliding window plus heap solution. Don't recall ever doing this, even if I solved this problem before. I set it for the first k values. Okay, so this one is find top x frequency by creating a heap size x. That has tuples of frequency value whenever heap is bigger than whenever heap's size is bigger than x. Remove the top of heap worst frequency. and then add or find sum of product of frequency times value in heap, append to answer array. Okay. And then this is close window on left, remove left side value from consideration, frequency. This one is open window on right, add right side value into consideration. Okay. So summary, this is going to be sliding window technique with extra data structures to keep track of heap and frequencies. Keep track of frequencies and heap. To find the best X frequencies within window. So in general, I actually have this values. So before kind of sliding for main sliding window, main for loop, set up the first k-1 elements. This is kind of prior to the window, which is to count frequencies of those values and add values to a value set. And then so that was this part. It's just to maintain, because the sliding window, the main for loop there is going to be you add an element to the right, you move an element to the left, add an element to the right, move an element to the left. You don't want to do this part before because it's not, it's just not part of the loop. It's kind of like set up right before the actual main loop. And then for main sliding window loop, so you have like add element, add value on right side of window, which is at like index, where index goes from k-1 to n, which is update the set, update the frequency, and then create a heap of heap of tuples of frequency value by iterating over the set, the value set, and adding appropriately. This is heap push. Maintain heap size of x, which is whenever size is bigger than x, heap pop. And then after completion, or after iterating over all values, calculate the total kind of sum of products and add that to the answer array as the appropriate value for that subarray, which is the window. And then lastly, remove value on the left side of window. So very similar to the right side. And then return the answer array. Okay. The point of using a value set is just to be quicker about determining which values are there. Otherwise, you could technically just go over the frequencies and find frequencies that are non-zero and add tuples of those onto the heap. But it is slightly faster to do this way. This is probably better, or this would probably show better performance even if there was like random values instead of values known to be from 1 to 50. Time complexity, this can be O of, let's say n k log k, O of n log k, what's this? I think it's O of n at least. We're sorting log k or k log k? Is it n times k? I think it might be O of log k. We're sorting k elements. Alright, I'm going to be conservative and say this of nk log k. As main loop iterates over every element of array and has a heap cost or heap instruction which should cost wait, k or is it x? K log x, x log x, k is not, oh man, what the hell's going on here? And k is the size of the subarray. It might be x log x actually. Where does k come in? This is really unsure. If I had a more growth mindset, I probably should look this up. But, which should cost, the size of the heap is x, sorting it within the heap would be x. It's k log x, because you insert into the heap x log x. Whatever. Space complexity, this is going to be O of k. No. O of x, since heap has size x. And I think that's the only thing you need. You technically do need to have a frequency counter, and that would be the size of the frequencies. also has a frequency counter array that has size of O of f, where f is the range of values that are possible. All right,